You know, as humans, we make hundreds, maybe thousands of decisions every single day. What's for breakfast? Which shirt to wear? Do I hit snooze one more time? But have you ever stopped to think about how computers and our apps make decisions? Because they're doing it constantly, and it all boils down to a surprisingly simple idea. So let's pull back the curtain and see how the magic really works.
I mean, really think about it. When you're logging into, well, anything, how does that program know you got the password right? Or when your favorite streaming service suggests a new show, what's the logic behind that choice? It feels super complex, right? But the foundation for all of it is actually the same.
At its absolute core, every single decision a computer makes boils down to this: answering a question with a simple two-part answer. Is this thing true, or is it false? That's it. This one idea is the bedrock of how all software responds to you, to me, to everything.
Okay, so how do we actually get the code to ask one of these true or false questions? Well, the most fundamental tool we have for that is something called an if statement. It's pretty much the starting point for all decision-making in programming.
Before we dive into any code, let's use an analogy we can all get behind. You wake up, you look at the thermometer, you've got this condition in your head, right? If the temperature is below a certain point, then you'll grab a heavy jacket. See? You're already using if logic without even thinking about it.
And this flowchart here, it's like a map of that exact thought process. It asks just one question: is the temperature less than 32? If the answer is true, it follows that arrow down and does something. But if the answer is false, well, for now, it just stops. It doesn't do anything else. It's kind of like a one-way street.
Now here's what that same logic looks like as actual code. You can see the keyword if, and right after it, inside the parentheses, that's our question. That's the condition. Then, inside those curly brackets, that's the instruction, the thing to do only if that condition is true.
So that question inside the parentheses, it has a special name. It's called a Boolean expression. And it's not just any old question, it's a statement that absolutely must evaluate to either true or false. Temperature less than 32 isn't a command, it's a test. And the result of that test is what drives the whole decision.
So, how do we build these Boolean expressions? Well, we need the right tools to compare different values. These tools are called comparison operators, and they're basically the grammar we use to form our true or false questions.
Using these operators, we can ask all sorts of questions. Is a number greater than another? Less than? Are two things exactly equal? Think of these as the fundamental Lego bricks for building just about any logical test you can possibly imagine.
Okay, you're going to want to pay close attention here, because this is a classic programming gotcha. In a language like JavaScript, you've got two ways to check if things are equal. The double equals is loosey-goosey. It might change things around to make them match. But the triple equals, that is strict. It checks if both the value and the data type are identical. For more predictable, reliable code, trust me, you almost always want to stick with the strict triple equals.
All right, so far our code only knows what to do if a condition is true. But what happens if it's false? Our program needs a plan B, right? And that's exactly where the else statement comes in. It lets us build a complete two-sided decision.
This question gets right to the heart of it. An if statement all by itself is like that one-way street we talked about. To create a true fork in the road, where the program has to choose between two totally different paths, we need something more. And check out this flowchart. Now our little decision diamond has two exits. If the password check is true, we go left. If it's false, we go right. There's an explicit path for both outcomes, so nothing is left to chance.
And here's how we write that in code. It's super simple. You just add the else keyword right after the if block. Now, the instructions inside the if brackets run if the condition is true, and the instructions inside the else brackets run if it's false. Simple as that.
So, here's the crucial point. With an if-else structure, the program must execute one of the two blocks of code. It can't do both, and it can't skip them both. It's a guaranteed choice, which is what makes our programs predictable and really reliable.
Now, we've been looking at JavaScript here, but this whole concept of if-else isn't unique at all. In fact, this exact same decision-making logic is a fundamental principle you will find in virtually every single programming language that exists.
To see just how universal this is, we can use something called pseudocode. It's not a real programming language. It's more like a simplified, human-readable blueprint. It just strips away all the specific syntax to show the pure logical structure. If this is true, then do this. Else, do that other thing.
And here it is.
Our password example again, but this time in that simplified pseudocode. Anybody, whether you're a programmer or not, can look at this and get the logic immediately. It's a pretty great testament to how simple and powerful this core idea really is.
All right, so let's wrap this up. What are the key takeaways? First, conditionals like if and else are what give code its brain, its decision-making power. The if statement handles the true path. The else statement provides that crucial alternative path for when it's false. And just remember, these simple, tiny choices are the atoms that build the entire universe of complex software that we use every single day.
So I'll leave you with this thought. We just broke down a single if-else decision. Now picture something incredibly complex, like a self-driving car navigating rush hour traffic. How many millions, or maybe even billions of these simple true-false decisions do you think it's making every single second to keep everyone safe? It's pretty mind-boggling.